Design is undergoing a monumental shift. The tools and principles that have guided us for decades are being augmented and in some cases, entirely rewritten by two powerful forces. The first, artificial intelligence, is already here acting as a tireless assistant. It drafts text, generates images, codes, prototypes, analyzes data, freeing designers to focus on higher-order problems. The second force, quantum computing, looms on the horizon. While not yet a tool for everyday design tasks, its potential to revolutionize optimization simulation cryptography means we must begin preparing for its impact today. For designers, this is not a moment of obsolescence, but one of profound opportunity. We must learn to design not just the products themselves, but the intelligent, adaptive systems in which they operate. This new era demands a new mindset. It is no longer sufficient to design a static screen or a linear user flow. We are now architects of conversations, curators of trust, choreographers of complex interactions between humans and intelligent agents. Our responsibility has expanded. We must ensure that the products we create are not only useful, usable, but also transparent, secure, respectful of user autonomy. To navigate the complexities of AI and quantum, designers need more than just intuition. They need a reliable map. The Quantum Design Thinking (QDT) framework is that map. It is a 7-step process designed to guide you from idea to a scalable, future-proof product. Each step is a logical progression, ensuring you build on human needs, system awareness, and technological potential. The framework is a flexible checklist that encourages iteration and learning. By following these steps, you systematically de-risk projects, align teams, and create responsible innovation. The 7 steps are: Signal, Human System Prototype, Test, Ship, Evolve. The journey begins with Signal, where you identify a meaningful shift in technology, behavior, or regulation. Next is Human, where you ground your work in real struggles through research and empathy. Then, map the larger context in System, considering data flows, constraints, trust implications. With that understanding, move to Prototype, using AI to quickly visualize multiple solutions. Test is about learning, gathering real feedback on prototypes. Ship a minimal, measurable product, then continuously evolve it to keep it relevant and secure. Every great design project begins with a signal. A signal is a small but significant indicator of a larger change. It could be a new technology reaching a tipping point. It could be a new law that changes the rules of business. It could be a subtle shift in human behavior. In the context of our masterclass, signals often come from the world of AI. Signals also come from the world of quantum computing. For example, the release of a powerful new language model is a signal. The development of a more stable qubit is a signal. The introduction of data privacy regulations like GDPR was a massive signal. Your first job as a designer in the QDT framework is to become a proficient signal spotter. You must train yourself to look beyond the immediate project. Scan the horizon for these catalysts of change. Finding signals does not require a crystal ball. It requires curiosity and a structured way of looking at the world. Ask simple but powerful questions. What new technology is becoming cheaper? What new technology is becoming faster? What new technology is becoming more accessible? What frustrating manual process is now ripe for automation by AI? What complex optimization problem, previously unsolvable, might now be approachable with quantum-inspired methods? Where will new security vulnerabilities emerge? What tools will be needed to address them? The goal is to articulate the change in a single, clear sentence. For instance, AI can now generate realistic synthetic voices from text. Post-quantum cryptography standards are being finalized, requiring system-wide updates. Technology is a powerful tool, but it is meaningless without a human purpose. After identifying a signal of change, the next crucial step in QDT is to connect that signal to a real human struggle. Great products aren't built for abstract users. They're built for people trying to accomplish something specific. Jobs to be done, or JTBD, makes this practical. Instead of demographics, JTBD asks, what job is this person hiring our product to do? You don't buy a drill for the drill. You buy it for a quarter-inch hole. Understanding the job is everything. To uncover jobs, talk to people. Quick, informal interviews beat long surveys. Your goal, understand pain, frequency, urgency, budget. Ask plain questions. Tell me about the last time you had to do X. What was the most frustrating part? How often does this happen? If you could wave a magic wand, what would be different? Listen for moments of frustration. Listen for workarounds. Listen for things people say they hate doing. Treat the signal as a potential new way to get an old, painful job done better. Identify several potential jobs, then prioritize them. A simple scoring exercise brings clarity. Make a small table and list each job. Score each job 1 to 5 across 4 dimensions. Pain, how frustrating is the current way? Frequency, how often? Urgency, how critical now? Budget, how much time or money will they spend? A product does not exist in a vacuum. It is a node in a complex, interconnected system of people, data rules and other technologies. Before you can design the product, you must understand the system it will inhabit. The third step of the QDT framework is to create a system map. This is not a detailed technical architecture diagram, it is a simple visual representation of the key components and their relationships. A good system map illuminates the invisible forces at play, where data comes from where it goes, who has access to it, and where things can go wrong. This step is especially critical when working with AI and planning for quantum, as these technologies introduce new kinds of risks and dependencies. Begin by drawing the actors. Who are the people and systems involved? Primary user, secondary users, administrators, AI models. Then, draw arrows to show the flow of data between these actors. What information is being created, shared, or consumed? Is it personal data, financial data, or operational data? As you map these flows, start to identify potential failure points. For an AI-powered feature, think critically about the risks of bias in the training data or the potential for the model to hallucinate and produce incorrect or nonsensical outputs. These are not edge cases, they are core design considerations. Security and trust are not features to be added later, they are foundational properties of the system. Your map must explicitly consider them. For each data flow, ask, how is this data protected in transit and at rest? How do we verify the identity of the actors? Identify the critical data flows that rely on public key cryptography, such as user logins or financial transactions. The fourth step in the QDT framework is to prototype, and here, AI becomes your creative accelerant. In the past, creating multiple design directions was a time-consuming process. Now, with the help of large language models and other generative tools, you can explore a wide range of possibilities in a fraction of the time. The goal of this step is not to create one perfect prototype, but to generate 3 distinct concepts quickly. Visual, 3 smartphone screens side by side, labeled Speed First, Trust First, and Delight First. For any given problem, you can design a solution that prioritizes speed, trust, or delight. A speed-first prototype focuses on efficiency, minimizing steps and getting the user to their goal as fast as possible. A trust-first prototype prioritizes transparency, control, and clarity, building user confidence at every step. A delight-first prototype aims to create a memorable and emotionally resonant experience, often using personality, animation, or unexpected moments of joy. Use an AI assistant to help you brainstorm and execute these directions. Prompt it to write user flows, generate screen layouts, and draft microcopy for each strategy. When designing features that involve AI agents, systems that can act on a user's behalf, your prototype must address levels of autonomy. Clearly design what the agent can do on its own, versus what requires explicit user permission. A simple model is to design for 3 levels: assistant, co-pilot, and autopilot, which acts automatically within predefined boundaries. Your prototype should show how the user sets these permissions, how they are notified of agent actions, and how they can easily intervene or undo an action. Prototyping error messages and onboarding flows is especially important here, as this is where you set expectations and build initial trust. Your exercise for this step is to produce 3 distinct prototype flows in just a few hours using AI as your partner. Use a tool like ChatGPT or a similar model with prompts like, design a 3-screen mobile flow for your task, optimizing for speed. Then, repeat the process for trust and delight. Don't worry about visual polish, focus on the flow and the logic. What are the key screens? What are the main calls to action? What is the tone of the language? Section 7, Step 5 and 6, Test and Ship. From real feedback to a measurable MVP. Creating prototypes is easy, creating prototypes that work is hard. The only way to know if your design is effective is to put it in front of real people. The 5th step, test, is about closing the feedback loop. This is not about defending your design, it is about learning with humility. The goal is to identify what is working, what is confusing, whether your solution is genuinely helping people do their job. Keep the tests short and focused. Give users a specific task to complete using your prototype. Observe their behavior silently. What do they click on first? Where do they hesitate? Was that helpful? Was there anything you didn't trust? What was the most confusing part? When testing AI-powered features, you need to add an extra layer of scrutiny. Look for moments where the AI's output could be wrong, biased, unhelpful. Run tests with a human in the loop, where you manually simulate the AI's responses. This allows you to intentionally introduce plausible errors and see how users react. Do they notice the error? Do they know how to correct it? This process helps you design effective safeguards, confidence scores, source citations, easy-to-find feedback buttons. The metrics you collect should be simple. Time on task, task success rate, 1 to 5 rating for trust. Section 8. Step 7. Evolve. The art of future-proofing your creation. Launching a product is not the end, it is the beginning of a new phase. The final step of the QDT framework is evolve. Technology, user expectations, and the competitive landscape are in flux. A product that does not evolve will quickly become obsolete. This step is about establishing a continuous cycle of learning, iterating, and future-proofing. It requires monitoring your metrics, listening to your users, and proactively addressing emerging threats and opportunities. The early work you did, mapping the system, and identifying signals will now pay dividends. Your immediate focus after launch should be on stability and trust. Use the first few weeks to fix bugs, respond to user feedback, and refine the most critical parts of the experience. Pay close attention to the trust and consent flows. Are users comfortable with the data you're using? Do they understand how the AI features work? Small tweaks to microcopy, adding a Learn More link, or a clearer onboarding screen can boost confidence. This is also the time to begin implementing your long-term security roadmap. Show timeline. Week 1. Fix bugs. Week 2. Refine onboarding. Month 1. Add PQC to login. Quarter 2. Test new AI model. As post-quantum cryptographic standards become production-ready, have a plan to update critical systems. The evolution of your product should be guided by a clear rhythm. A weekly learning cycle is a powerful tool. Every week your team should meet to answer 3 questions. What did we learn from our users and our metrics last week? What is the most important problem to solve or opportunity to pursue right now? What is the smallest change we can ship next week to address it? This cadence keeps the team focused and the product improving in ways that matter to users. Your exercise for this step is to plan the first month of evolution for your product. Week 1, improve the clarity of error messages. Week 2, add a "Was this helpful?" button to all AI suggestions. Week 3, A/B test 2 different headlines on the main screen. This forward-looking planning forces you to think beyond the launch. The capstone, putting theory into practice and pitching your vision.